Figure 5.2 shows a circuit with a battery of EMF 12 volts connected to a linear potentiometer AB and two identical lamps. So this lamp here and this lamp are identical, meaning that they've got the same resistance. They behave the same way with the same amount of current or the same PD across them. They behave the same way. The battery has negligible internal resistance. This battery has negligible internal resistance. The lamps have IV characteristics shown in Fig 5.1. So these lamps, both of them, they behave according to the graph there. And the slider of the potentiometer is at the midpoint. This slider, if it's here at the midpoint, what happens? The current I in the battery is 1.78. So the current that will be flowing in that battery will be 1.78, and this one is at the midpoint. So what is the implication of this being at the midpoint? Now you must understand that we have 12 volts here across these 2 points. So if we have 12 volts across these 2 points, the same as we have 12 volts across these 2 points, this lamp is similar to this lamp. So meaning that the potential difference here is, since the lamps are in series, the potential difference across this lamp and across this lamp will want to be equal. Not always, of course, but in this case, because of that. So likewise, the potential difference here is 12, but this is in the midpoint, meaning that the potential difference from here to here is 6, and from here to here it's 6. Likewise, from here to here it's 6, and from here to here it's 6. So if that is the case, then it means that the potential difference from this point to this point, it's 0. Why is it 0? Because the potential at this point is equal to the potential of this point. So current will not flow in this pathway. Current will not flow in this pathway because to some extent what has happened here is this one. Had this been connected somewhere here, current would flow. Had this been connected somewhere here, current would flow. But by putting it at the center there, it means that on this side the resistance is equal to the resistance on this side, just like the resistance here is equal to the resistance on this side. So these guys will share voltage equally, meaning that the potential at this point and the potential at this point will be equal. So the potential difference here will be 0. Continue. The potential difference here will be 0. So if potential difference is 0, we know that current is voltage over resistance. So if potential difference is 0, then it means that there is no current flowing through this region. Why is that important? It is important because even if a student had not understood that, the implication of this being at the midpoint was intending to make sure that you understand that the current here is equal to 0. But sometimes the student might ask, why does it matter? It matters so much, even though you could work out this question without understanding that, by simply saying that there is 12 volts across both of them. So since they are of equal resistance, they would share that voltage of 12 equally. So that this one is a voltage of 6, this one is a voltage of 6. So if there's a voltage of 6 in these lamps, then we will go here for a voltage of 6. Then we'll go here. Now each box is representing 1.5, 1.6 here. So 1.7, 1.8, 1.9. So meaning that there is 1.55. So the current in this case is 1.55 amps, according to the graph. Then the next question says the total power dissipated in the lamps P and Q. Power, we know the voltage across the lamps, we know the current through the lamps. The voltage across each lamp is 6, and the current through each lamp is 1.55. So VI then multiplied by 2, since there are 2 of them, the lamps, then that will give us the power dissipated in both the lamps. Then next, the resistance of the potentiometer between its and between its ends A and B. So the question is looking for the resistance of the potentiometer between its ends A and B. So you have to look for the resistance of the potentiometer. So to look for the resistance of the potentiometer, we must look for the current through the potentiometer. Remember, we agreed that no current is flowing here. So if no current is flowing there, then current comes here, which is 1.78, splits, some of it goes here, some of it goes here. It goes like that, it goes like that. So joins again here, becomes 1.78 again there. So since 1.55 is coming here, then the remainder will come on the other side. So that's what we're doing here. We're using Kirchhoff's first law. I is I1 plus I2. Then 1.78 is the total current. 1.55 goes the other side. And I2 is the current we're looking for. So I2 will be 0.23. Then having found the current through that other resistor, the potentiometer, we then say the voltage across it is 12 because it is in parallel with this one. Even if we are going to consider Kirchhoff's second law for that particular loop, where we are considering the EMF of 12 of the battery, then the current through the resistance is 0.23. So the resistance of that resistor is 52. Then finally, the slider of the potentiometer in C is moved to A. State and explain the effect on the brightness of the lamps P and Q. So we want to know what happens to the brightness of P and Q if it is moved to A, the slider of the potentiometer. So check out this one. If the slider is moved to A here, what will happen is this. If the slider is moved to A, when current gets to this stage, current, you must understand how current behaves and how current prefers to move. In this case, if it is moved to A, there will be a split of current here. But you see now, current comes here like that. But here, there will be no resistance in this pathway. So current will prefer to go this pathway than to go this pathway. So current will just flow like this into the lamp Q and goes back to the battery. Of course, it has been provided with an easy way. Some might go this way, but however, none will go through this way in that case. So there's no more current in this one. If there's no more current, then power is I squared R. So no current, it means that power will be 0, so brightness will be 0. But this, since it is no longer sharing current, and also the potential difference, since it is connected to these 2 points, this point and this point, the potential difference across this lamp is now 12. So power across it is V squared over R, which is 12 over squared over its resistance, when it used to be 6, meaning that the voltage across it is now increased, which means that it has now more power, so it becomes brighter, lamp Q, because of that. So it's important to understand that lamp Q becomes brighter because the PD across it is now 12, whereas the PD across the other one is now 0 because current is no longer preferring to go that pathway.